It should be another draft physics video presentation. Hopefully. A wall to draw on. That's what I'll try doing. Maybe. See how the video goes. So yeah, not much to talk about in terms of other people interacting in any kind of real way. And that's unfortunate. That there's just nobody willing to have conversations. They're all isolationists, essentially, and doing their own thing. And I just think that's to all of our detriment, that we don't challenge each other or question each other in some sort of back and forth kind of manner where both parties have to answer questions and all of that kind of thing. But anyway, and no comments. So I'll take that as I'm winning. Basically just because there's just no counter arguments to anything I'm saying. Just no, except for rags about my hair or something else, there's just nothing stated as you can't do that, that won't work, none of that. Anyway, so Panda Woot, which is again the troll account, I don't know exactly what it means, Woot, whatever, I don't know. Admit it, the only reason you make videos is just to hear the sound of your own voice. No, I mean it's kind of silly. I mean, it's a statement. So do you think this happens regularly? I mean, there's lots of people on the internet are talking about things that are kind of irrelevant, little narrow niche subjects and all that kind of stuff. So on my two channels, I mean, one, I'm taking the very meaning of being alive and being a consciousness on this planet and what kind of value is at stake. And this channel, I'm talking about the elements of physics. What else is going on? I mean, I do like the sound of my own voice, it's true. And I do I do seek to understand things correctly, and I seek other people's opinions, and I've listened to zillions of them, seeking some sort of wisdom or some sort of reasoning, and they all fall really short, really, really short, like religion. So anyway, fuck you. I mean, what an asshole. What kind of dirtbag raised you? You just don't think that you think that's a reasoned argument against somebody's position, is to just say something stupid like that. Ugh. Puke. Alright, don't get this. You don't agree with his views, his language, or his beliefs. Well, I don't know what you mean by his language. I'm just making critiques. Yeah, so you think everybody should just be allowed to say whatever they want and nobody should critique anybody. And they shouldn't critique about things that actually matter, like being comprehensible. I mean, I'm not complaining about his language. What I find laughable is that any of the sycophants listening to him and applauding have any clue what the fuck he's saying. That's my challenge, is that I would love to be able to challenge any of his followers to be able to recite in any kind of form or draw in any form what he's talking about. And clearly I think his beliefs are idiotic. Yes, this Stone Age crap. Let's go back to the mystics of 2,000 years ago to find the truth. Sorry, that's not where you're going to find the box of truth. Shit. Stop stressing yourself and don't watch him. Well, I don't watch most of his videos now. The camera ones, I just couldn't give a shit. So the only ones I watch is when he starts pontificating on some subject of the meaning of anything, because he has all of those things fucking wrong. But this idiotic, don't argue with anybody. Everybody should just be allowed to say whatever the fuck they want and nobody should challenge any of it. I'm challenging him. You don't see that happening, and he's the coward, the one afraid to defend his nonsense. Hey, do you have a Patreon account? This subject keeps coming up, but I mean, I would be insulting you if I had a Patreon account. My opinion. I'm insulting your intelligence. Because we're basically agreeing that, well, let's just lose another 3% of the money, or 4%. Let's just throw it away. because you can't hit a donate button or something. You can't find some other way to do it. So you need Patreon to somehow do something for you that you can't muster. You can't figure out how to do it. You know, you need them to take the money every month. You can't just say, oh, I'll just pay a bulk payment. Or you can't, I mean, I'm just saying, I'm just insulting your pay. You know, it's the last thing in the world I would ever do is be a Patreon contributor and just sit there and say, oh, okay, PayPal will take some of the money and then Patreon takes some of the money. Why would I pay two assholes? I shouldn't have to pay any assholes to transfer money in my bank to your bank. It should be for free. Fuck. I'd be willing to pitch in a few bucks per month. It's like buying a guy a beer. Fine. You know, I obviously, thank you. I could use money. Money is fun. But yeah, I'm not gonna solicit it hard or anything. I'm not gonna beg for it or say I can't go on without it. None of that's true. So, but you can go to my website, DraftPhysics.com. There's a donate button right at the top of the page. Hit that, and PayPal will take its little cut, and that's it. Because there's no other cheaper way to do it yet. You know, short of me having your bank account number or something. I mean, it just is annoying that we have to go through these stupid fucking useless capitalist shitholes to do something that should be free. It's like even having domain names. I mean, it's getting more and more expensive. It's over $15 a month now. I mean, a year to rent a name. You know, nothing. It's nothing. It's a little bits in a computer. It's just nothing. And we have to pay for it just to make somebody else rich, or give them a lazy ass, don't do any work job that they get money for. But it's all horse shit. So I don't mean to insult you, but I'm just saying Patreon's for idiots. Yeah, sorry. You have to be an idiot if you need Patreon to do it for you. I mean, you're just too dysfunctional for me to relate to. All right, so enough of that. So that's it. I mean, the comments are just nothing. All right, so I did listen to the Rational Science guy and his latest video, and it was an overview of his conference, but he really is sort of just completely full of shit on some subjects, especially making these semantical distinctions between objects and objects in motion, which is, somehow one thing's a real thing and the other thing's not, which is stupid. Just these whole ways of trying to start the conversation about, I agree with him in the sense that what conventional physics gives you is a bunch of unknown mechanisms, virtual photons for magnetism, and it still doesn't explain why there's attraction and repulsion. They're just saying the carrier of the attraction and the repulsion is some sort of thing we invented that doesn't have any reality. We can't account for its existence. It's virtual because they can't account for where it comes from. It does something energetic, yet we don't have an excuse for the energy, so we'll just say virtual photon. People say, okay. Now that's silly. That's not an explanation of magnetism. Doesn't tell you anything. Doesn't tell you why it attracts at one end, it repels at the other. Doesn't explain anything. And then space is the same kind of nonsense. Planets move, and yet they say, it's just space that did it. Nothing was bent by a mechanism that bends the nothing. But we don't have any description of the nothing or the what bends it or how the bending makes something move, and the whole thing makes no sense in 3 dimensions. And yet you people say, okay, that's an explanation. No, it's not an explanation. It's horseshit. It's not physics. It's not science. It's mysticism. It's crap. It's just a bunch of invisible men or God. You might as well just say God space did it. Bent God space. There's no explanation. And physics is just founded on all this kind of crap. Dark matter is just an invention. Entanglement is so weakly evidenced, yet they all are so confident it's just some sort of real phenomenon that things really, it's not. The obvious explanation is there's left-handed and right-handed particles, that they come out north and south, or they come out east and west. They come out in some way opposite, and that's the character they have, is this little thing that was different about their creation. And instead they go for this wooey thing that somehow they don't know what they are, and then somebody has to measure them to decide for them what they are. The whole Schrodinger's cat crap. And somehow people say, okay, that's acceptable. And again, the evidence is just almost non-existent that any of this is a real thing. That it's not just simply the fact that these things are not measurable. You can't test them any other way than to terminate them. And so what's what's the point? You can't tell what they are and then let them do something, because you can't tell what they are when they're doing something else. So once you've changed them, there's no point in talking about, well, this is what it was, and now it's not what it was anymore. Oh, what a surprise. Anyway, it doesn't make any sense. It's just so weak. All right, so we go right to the beginning arguments, and so this is what I like about the rational science guy. That at least he points out these. Well, where does it come from? What's actually in the universe? What are the pieces here that we're talking about? What do we have to follow? Where's the ball? What's the elemental stuff? And so one thing you can see everywhere in the universe is pressure. Everything is somehow being pulled towards something. Or, obviously I'm arguing pushed, but what it looks like is that everything is held together in a form that doesn't seem like it would want to go out. It wouldn't want to stay where it is. So something is pulling it together, or pushing it, as I would argue. So that's the basic diagram. Let's see if that's visible. Barely. Okay, so this probably isn't going to work. All right. So my point would be is that everything is being pushed from the outside. So atoms. So you start with the atoms, and if you go to the smaller bits, okay, like electrons and protons, which you can barely see. Yeah. So maybe I should try to get the other camera going just for the purpose of drawing a picture of it. Well, we'll just finish with this since we started. Maybe I can find a better marker than this grease pencil. Anyway, it doesn't really matter. All right, so so you could say, okay, the atom is something we can understand. Electrons, protons, and the neutron, which is a collection of electron and proton really close together, let's say. That's what it's a composite particle, made up of the two. So those are elemental particles. You could say those have elemental functions. The atoms function because of their charge. And this is another thing. Nobody accounts for charge, and some people just wish to say it doesn't exist, which doesn't make any sense at all. I mean, you can't negate its existence. It's just too fundamental to everything that happens in physics. It's all over the place as a phenomenon. You can't just pretend you don't have to account for this profound difference between electron and proton. But even conventional physics, here we go again, they have this notion that electrons have polarity, that somehow electrons have a positive part somewhere, which doesn't make any sense, because there's absolutely no evidence that they're ever repelled by a proton. There's no evidence that they are, they ever can attract an electron to another electron because you attract it to its proton end or something, its positive end. Well, anyway, so they've tried to make electrons into dipoles when there's just no evidence they have any pole. They're clearly all negative, and the proton is all positive, and there's no changing that. And the only thing you do is range them in different ways, and then you can see the net effect of an atom is different. You can see polarity in the atom, but you can't see polarity in an electron. And yet conventional physics has made up some sort of polarity, and they've made it out of nothing. There's no reason for it. So anyway, so all you need is this pushing idea. So if you have a universe of simple bits, and you knew if you just made the universe out of, like, say, cosmic background radiation, and just made more of it, it would act exactly like gravity. And you could theorize that everything inside the atom would also be affected, in the sense that all the little bits that were bigger than the force bits, the photons, basically, would be pushed. They'd acquire acceleration and they'd move. All right, so another fact I want to get to, another part of this that's kind of important that I probably should do drawings for, but anyway, is the idea that when you do experiments with springs or mechanisms that you've taken away the friction, like air beds or something, or things that can move without friction, you really get the idea that this system could just keep going. Like you could pull a spring and it would just keep going forever. So if you could get rid of these little bits of friction, the energy you put in stays in the system. Theoretically, it could stay in the system for a very, very, very long time, and all you have to do is get rid of this stupid friction stuff. So it's sort of the idea that the energy of the force is perpetual, and that if you can keep the force in the system, it will show itself to be perpetual, in the sense that you will create a pure reflection of a force. And the pure reflection is basically an absorption and a readmission. And so the force is always in the thing, and it's only in our big world where everything leaks so much of the force that we sort of lose sight of the fact that when you gain velocity, or when you're accelerated, that you sort of are, it's real energy that you're possessing. And that's why things can keep going in space, is because it's real energy that there's inside of them, and that real energy is still moving, and it ends up moving in one direction primarily, the direction it came in, and it just moves much slower. So the force goes in, the force gets spread over the object's mass, and however heavy it is going to dictate how fast it's going to go with that much force. And clearly that's what we see in gravity, is that if you put one little force bit in, one quanta of gravity into something, they'll move at different speeds based on their mass. But if they can collect as much force as their mass representing their mass, then they'll move at the same speed. And that's why they move at the same speed, is just because more force is absorbed by the thing with more mass, and less force is absorbed by the thing with less mass. So, so it's just kind of a fundamental thing that we don't really see the universe as most of it functions. So the small universe is functioning in that world where there isn't a whole lot of leakage. Stuff goes in and stays in systems, and we're living in a world where we see all of this dissipation, because there's always stuff around something to absorb the energy, and so there's stuff that would go back and forth ends up moving stuff sideways and in lots of other directions because it's radiating a bunch of heat, and so it's losing the energy. The energy's moving other things besides the things that you want to watch move. So you're watching something moving, and that movement is leaking slow but sure out of the system, and that's how we see most things, where on a nuclear level there is no friction, there is no heat loss, there is none of this. It can go somewhere else. It can break into pieces. Pieces of it can go somewhere, because the individual bits can't be reduced into something more elemental. All right, so I got to this conclusion through a path. Okay, so for me it started with photons, and they said photons are doing this in some kind of field they're waving through, and none of it made any sense to me when I heard it. And as a kid, I said plainly then, it can't be that way, they've got that wrong. And then later I found out they had even wooier explanations when it came to the fact that when light interferes with surfaces, they have this whole notion that all this bizarre crap happens, that the photon goes through two slits and interferes with itself and does all kinds of other nonsense, and that really sounded so crazy. And so I went and looked for some kind of better explanation, better understanding. And so I went with my understanding of what a photon seemed to be, which was bullets at a period. That's the frequency, clumps of momentum, and they could be just illustrated as bullets, and they came in rays, and the ray can be a little bit out of alignment. That could be because of polarization. So all of that stuff became developed as my understanding. Some of it I had, and some of it I picked up over the last couple of years to refine my understanding. But I started with that as my initial cause to start thinking about what gravity was, and then to think about what polarization was. So gravity to me was, well, clearly it's doing the same thing that photons are doing, in that it's imparting momentum on us. Now it's clearly a much denser force. I mean, again, I've made the point, to move this sideways with light would take an awful lot of photons. Yet, when I let go of this, it accelerates quickly and dramatically. And so they keep talking about how gravity is a weak force. Well, clearly it's not that weak. But it would take a lot of energy to move mass with photons. And part of that's because of the fact that we can't create photons with anything like 100% efficiency. But regardless, it's still a lot of energy to move things like gravity does. A lot of energy. So anyway, so I started with photons, and then I thought about gravity, and I said, well, what if gravity was like a photon? It's just one we can't detect, because it's not at a frequency. It's not at a long enough ray. You need a long enough ray to detect a photon. And if the ray of bullets isn't long enough, then the electron doesn't react the right way, and you don't see it as an electrical event that we can detect. But it's still moving the electron. So the short rays is still moving the electron, still imparting a force on it. And so what if that was gravity? We wouldn't be able to detect it any better. We can detect gravity by watching it do this. We don't have some special instrument that can tune into the non-frequency, because there isn't enough frequency. And so we're blind to it in terms of detecting it with some instrument, but we can know it's there, because the fact is the electrons and the protons do move, and the thing that's moving them is the gravity. So anyway, so then researching that, it came up with this Lesage thing. I found out was an early attempt, more than 300 years ago. Somebody was smart enough to figure that out, that gravity is basically a pressure from the external world. And if you had little tiny ultramundane particles, little bullets coming from outer space, like the cosmic background radiation, and you had enough of them, they would do exactly what gravity does, in the sense that one object would shield another object from the impacts of the force. That means if I'm getting hit by more stuff behind me than in front of me, I'll move forward, because there's more momentum hitting me from behind than in front. And likewise, the thing that's facing me, that I'm being gravitationally attracted to, is going to do exactly the same thing, depending on how much of a shadow I cast on him, how much extra energy I absorb from behind me. Well, that's all energy that won't hit him in his front, and therefore he'll move towards me. And that's exactly what gravity does. The proportions all work out. It works fine. They call it mock gravity because it works really good to explain gravity. And so I kind of knew I was on the right track because, yeah, it's a great idea. Somebody already had it 300 years ago, and it makes perfect sense. And they threw it out merely because it causes this drag problem if there's an actual force in the universe, blah, 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 blah. Now, the drag gets kind of a complicated issue because it really has to do with electrons and protons, and how they absorb momentum is the reason why there is no drag issue for atoms, because atoms are different than, well, let's say atomic nuclei are different than electron and protons. So as I've explained, electrons and protons clearly do experience drag. We can't keep them moving forever. We can't shoot a beam of electrons to the moon and bounce them back. We can't do anything like that, because the electrons need to keep being pushed by something because they run out of fuel. They do leak their momentum to the environment through a drag process, and atoms don't. So if I throw a wrench into space, the wrench will keep moving because the electrons and the protons are acting with each other to overcome what would be their drag issue. So anyway, like I said, it's a complex kind of argument to make, and I'm not saying just trust me. I'm just saying the drag issue can be understood because it can be understood that the elements aren't the same as the composite particles, and composite particles can have a motor. Their boat can have a motor. They can have a mechanism that keeps them going upstream, so to speak. So there are ways to understand it where you can understand that this problem they say that is critical isn't a critical problem, a fatal problem. And like I said, the model works so well that there's every reason to give it every benefit of a doubt. So having one thing that you can't explain shouldn't make you think, oh, the model can't possibly work then, because 99% of the model is perfect. I mean, it explains why there's an inverse square law. It explains why things go spherical. It explains all the gravitational phenomenon observed. So it makes perfect sense. Right, and so then I got to the magnetism thing, and so this was the hardest one, and charge. And so understanding those two things, I mean, first you kind of realize, well, there's this obvious similarity. North-south poles on the magnets are really similar to the idea of positive and negative charge. And then you have to do the charge thing. You have to understand, well, we have this thing called charge moving through a wire, which we call electricity, which is sort of a different phenomenon because it really isn't about charge. It's about atoms transmitting force. So you need the conductor to make the electricity thing happen. So electricity is completely dependent on atoms existing. If the atoms aren't there, the electricity is not going to be there. So that you can put in a little bit of a separate category and say, well, that's not really the nature of charge, electricity. Charge is something more fundamental. And if you really think about it, it's so fundamental, it's so elemental that you can understand that electrons and protons are really the magnetic monopoles, that they're really what's causing magnetism. And it's just a charge phenomenon. It's just a phenomenon of the fact that you have these two polar differences in charge, plus and minus proton, electron. So once you figure that out, you say, yeah, that makes sense. This has to be unified. All these forces move the same speed. Another thing needs to be understood. So, so yes, clearly charge has this element of understanding that where's the energy come from. So that's another argument you can make. Clearly magnets move into each other. Conventional physics has no explanation for where the energy comes from. No batteries are burned, no nuclear energy, no anything. There's no evidence of any place that the energy is acquired from. So you have to understand that, well, the place it's got to be acquired from is from the outside. It can't come from inside. Because we already know it's a certain number of atoms. They have a certain amount of momentum locked in them, a certain amount of energy, and they're clearly not losing it to the environment. So whatever this force of magnetism is, it has to be somehow a conversion of a force that already existed. Something that's already in the environment. And that's when I came on the simple idea that magnets are just filters. They're taking, when gravity comes in, gravity comes out of a magnet different than it comes out of you or me. It comes out segregated. So the gravity segregated. Now the amount of force going both ways is still the same exact amount of gravity. There's just as much gravity coming out of one end as gravity coming out of the other end. Force being reflected or going through. So that's how something comes in. It's like energy comes into you. Some of it reflects, some of it passes right through you and goes out the back. This external force does that. So if you're polarized, then the force can reflect off one part of you and it can absorb by another part of you, depending on whether that part is made more of protons or electrons. And that was sort of the key thing to realize. is that all that charge really was is that the things were inverted. Okay, they were doing the same thing, they're just doing them exactly opposite. So they're just opposite filters. And so if you understand that, what would it be filtering? Well, it's filtering a force that's in the field already. So all you have to do is polarize the force. So as long as you understand that the little photons have a plus and a minus, a electron force, a proton force, that the force bits are red and black, or blue, whatever, that they have two distinctive type, and the two type can be filtered. Well, now you can make a magnet, because now whatever force goes in, it goes in mixed, black and red from all sides, into a magnet. And because the black reflects off the black side and the red reflects off the red side, the north side and the south side of the magnet, and is transmitted, wherever goes in comes out the other end, so it's all just filtered. So you're just filtering something that was mixed, and now you're making it polarized. This light's twitchy, I don't know why. Blinky. I have to see if I can fix that. I don't know what's the, well, anyway, oh god. Whole circuitry of this house needs some work. Anyway, so if you do, magnetism can be completely understood by just understanding that what's happening when you have a magnet is that you're taking a mixed force and just filtering it for red and blue, and the other magnets can see the red and blueness, because if you send electron force into an electron, it reflects. If you send electron force into a proton, it's absorbed and creates momentum, and vice versa. And then you can fully understand the mechanism of attraction and repulsion between electrons and protons, is that they acquire momentum. The key thing is they acquire the momentum on reflection. So when a force bit hits an electron, what it's really doing is making an exchange inside of itself. So if it had, 3 things going this way and 2 going this way, and you hit it with one going this way, it'll give up one going that way. So now it'll only have one going this way inside of it, and it'll have 4 going that way. So it absorbs and exchanges. So it's like this perfect reflection of 2 things hitting each other and bouncing off. Now if they're the same color, the universe doesn't change. But if they're the same, if they're different colors, well then you'll see that blue goes this way and now red's going that way, completely opposite of what it was before. And that's what electrons and protons are essentially doing. They're making exchanges. They're taking something going this way and giving back something going that way to the field. To do that, they themselves have to sacrifice their balance, and so they're going to give away energy going this way and keep energy going this way. So in net, they've lost some drag, they've lost somebody going the wrong way, and they've gained another component going the right way, so they've almost doubled their energy. So a reflection, technically, is more momentum than an absorption, if they could absorb without, if they could absorb in one direction, which they can't do. So the rule is they have to make the exchange. That's the only way the new thing can stick, is that there's only a certain number of seats in a lifeboat. So what you're saying is everybody's wearing red shirts or everybody's wearing black shirts. And to put somebody in with red shirt, you have to throw somebody out with a black shirt. And you can see that over time, if you keep adding red shirts, you keep losing black shirts. You'll very quickly, with every addition of a red shirt, you're not only adding a red shirt, you're losing a black shirt, and vice versa. So the balance is always dictated by the fact that all what we think of as energy events are really momentum exchanges. So anyway, but then this ties everything together. So once you understand that that's the real mechanism, that this is all about just absorbing energy, you have to absorb the energy to create gravity, in the sense that I have to move. To move, I had to absorb stuff going that way, I'm moving, and I gave back stuff going the wrong way. But I'm actually moving, but I don't move the speed of light. So when I move, I have to absorb a lot more stuff going the speed of light, then is reflected in my movement. And in a sense, that's where you're creating gravity. So to move, you absorb energy, and when you move, something else doesn't get hit with the energy. So the energy is always moving the speed of light, the cosmic background radiation, if we're going to use that concept. The external force, the pressure of the universe, is always moving the speed of light. It never slows down, and all you can do is trap it in circles or squares or going back and forth. Still works. Like the spring. You can just trap the energy in an oscillation between two paddles, between two electrons. So anyway, I have gone through all this in previous videos and the bits and the pieces, but it all fits and explains everything we see from the big universe, the pressure pushing things together. It makes it understandable to understand that atoms are forced into their configuration because of this external pressure. And that the pressure is very specific. The electrons repel each other, the protons repel each other, but that was one of the key points I brought up. People were like, well, you have to have this incredibly strong force to be able to get two protons so close to each other, so the nucleus has to have some super energy in it. And it really doesn't, because all you need to do is put one electron between the two protons. That would be the electron that's part of the neutron. And you know, all the reflective energy of the protons will leak out through the electron, and all the energy, you know, so it just creates an escape valve for the pressure. And that's why you can bring two protons really close together inside the nucleus, is because there is an electron in between them, and that electron is leaking all of the proton hostile energy perpendicularly, and vice versa for protons. You want to get two electrons close together, put a proton between them, and you get them closer. So in atoms, if you can get two electrons on either side of the nucleus, those electrons can appear to have more energy because they can be closer and closer together. But there's really not more energy because there's no pressure. They're letting the pressure out. They're releasing it. Alright, so what else do I need to say in summing this up? But I'm just saying this works all step by step. You can put this whole thing together in a nice physical model that has very few parts. So all you need to do is believe that there's something called force bits, which move the speed of light, that make up what photons are, and they make up what gravity is. Gravity moves the speed of light, and magnetism moves the speed of light. The EMF, you know, electromagnetic forces, or whatever you want to call them, all that stuff moves the speed of light. All the stuff that's force, that just exchanges momentum, that causes things to move, all of that stuff moves the same speed. And all you have to understand is it has two properties. There's electron force and proton force. There's red force, black force, however you want, round force, square force. And that protons and electrons interact with those forces, the square bits or the round bits, red bits or black bits, exactly in the opposite way. So for an electron, any proton force that hits it, it releases perpendicularly. Any electron force that hits it, it reflects. And it reflects in the sense, as I just told you, it absorbs the energy going this way, and it releases a piece of energy going the opposite way. So it gives back the universe an opposite force bit in the opposite direction from the one that hit it. And that explanation explains all the movement we see in atoms, and all the movement we see in solar systems, and all the movement we see in galaxies, and all the movement we see in the universe. You don't need anything more than that simple explanation of this interaction between protons, electrons, and the two kinds of force. So that's all there is. Force bits moving the speed of light. The matter bits are dead. They're boats. Okay, they don't go anywhere, only dependent on who's sitting in the boats. So if 5 red shirts are sitting in it, 5 black shirts going this way and that way, they don't go anywhere. If you make those numbers uneven, that they have 7 guys going this way and 4 guys going that way, then it moves in that direction, the boat. So it moves in the direction of imbalance. So if you can imbalance what's inside of an electron, you can move an electron. Same thing with a proton. But it's just about creating an imbalance in its internal condition, in terms of what it has captured inside of it. And then there's also the momentum you can trap between electrons and between protons and atoms, so that adds another bit of momentum to the system, or tension, or pressure. Let's see, anything else need to be said? But electrons keep moving. They keep being imbalanced until they're balanced, until there's enough force hitting them one way and it's balanced with the force hitting them the other way, so they always end up with 5 and 5. They always have to be in a position in the environment where they're always getting hit by enough force where they move, you know, if you have a ping pong paddle bouncing back and forth, and a certain number of hits. And that number of hits doesn't undo the imbalance you have where you have a tendency to move in. Well, if you move in, then there's going to be more hits here. So if I move this electron in because it has some momentum, it's moving, its imbalance will be altered because now it's going to get hit with more energy and it'll move away. And it's going to stop moving away when the numbers become even. You know, it might oscillate a little bit, but the whole idea is it's going to end up being 5 and 5. So it can come in 3 and 7, and it's going to be converted into, you know, 6 and 4, and then it'll go to well, can't go to 5 and 5 yet, but you know, it can oscillate, and then it's going to stop and freeze into a position that's a certain distance from this electron and a certain distance from the energy that's hitting it from the rest of the universe, and that's its balance point. But everything's seeking that. So there's no such thing as a free electron. There's just no concept. Electrons have no native condition. Their condition is entirely dictated by the environment around them. So they're always going to be moving until they find a balance, a position that forces them into balance. So you know, lots of these physical concepts become so crystal clear. You know, that there just isn't anything called a free electron. There aren't electrons just freely moving. They have to be forced wherever they go. And yes, the electrons can be hanging around in the sense they're not essential to the atom structure. They're peacefully resting on a field of atoms below them. They're just resting as a balance between the electron pressure from the atoms and the external world's attraction and repulsion. And there's a balance, and they sit there. And then if you put a force going this way, say, well, yeah, you can move them sideways. You can move them in a direction, and that might be called electricity or current, but you're really just moving pressure again. You're just saying, I'm going to move an electron in. That's going to create more pressure between the electrons. The electrons are going to expand. So if this one comes in with momentum, then this one's going to leave with momentum, and the next one's going to leave with momentum, and that's all that's happening. You're just transferring pressure. Alright, so the whole universe is just pressure. And it's pressure created by a real force that's made out of real stuff, bits of stuff, momentum quanta, a quanta of energy. And this quanta of energy moves the speed of light, and it can be captured by electrons and protons. And that's the universe. And you know, just follow the momentum, follow the quanta bits, because they have all the movement. All the stuff moving the speed of light is the only place any movement ever comes from. So when I move my hand, the stuff that's moving my hand is moving the speed of light. And this is just a conversion of that motion over lots of different pathways and turns. My hand doesn't move. The force doesn't hit it and the hand move. You know, the speed of light doesn't hit something and the whole hand moves the speed of light. It has to be spread over the whole object. And so when my hand moves, there's a whole bunch of forces doing lots of stuff to incrementally move it, but each one of the interactions on the atomic level are at the speed of light. The force moves the speed of light, and the electron transfers that speed into something much slower, and then the atoms transfer it into something even slower. So it's really just taking the momentum, spreading it over the material bits, the atoms and the electrons, and it takes energy to move the mass. That is, you have to hit it with a lot of force to create enough imbalance to move the whole atom. So the atom appears to have the more momentum, but its momentum is completely made out of the elemental bits. So the electrons and the protons are really the bits that have the momentum. So when you move in gravity, what's moving are your nuclear bits. The little tiny electrons and protons are really moving towards the sun and towards the center of the earth. The atoms really aren't. The atoms are just following where the electrons and protons are going, and the electrons and protons are just following where the force field potentials are, how much force they're getting hit by, based on whether they're shadowing each other. That's it. You're in proximity. Okay? I mean, again, this simple analogy for energy. Energy, there's a thing moving the speed of light in here, just going like this, and it's moving this one speed, and I capture it in between two paddles. All I have to do to create more energy is just move the paddles closer together, and I'll double the number of impacts. So the impacts are always at the speed of light. The force bit always weighs the same, so the momentum is always the same amount of momentum. And it appears like a reflection. As I've pointed out, it's not really a reflection, it's an absorption and a readmission, but whatever. But the point is the closer I make them, the more energy is going to be, appears to be there, because there's more impacts. But all I did was move them closer together. So proximity, pressure, that's what energy is made out of. Okay, what we call energy. That's what creates imbalances. Yeah, that's probably enough for this video. Maybe I'll work on this. Maybe crayons. Yeah. Or maybe it's not a great idea. Maybe I should get the pad of paper to work better. Yeah, it's probably going to work better anyway. So I should just do that. I should get the camera working. And so I'll do that. I have this as a backup in case I need it. Alright, so that should be enough. So, till the next time, and such, and so forth, and the whatnot. That's not what I want to do. Save recording.